In this lesson, we're going to do a quick overview of the concept of linear functions. Linear functions rely heavily on the idea of equivalence. You have seen the vast majority of this content before, so we're just going to very quickly run through the ideas of slope and the different representations for linear functions, how to graph and write equations of lines, and some different tricks that you can use to help you out depending on the form that you get. Let's begin with the idea of slope. The slope of a non-vertical line, so any line that is not up and down, is the ratio of the vertical change to the horizontal change between 2 points. You probably remember this from Algebra 1 as the concept of rise over run. So this is typically rise over run. The slope of a non-vertical line through 2 points, x1 and y1 and x2 and y2, is the ratio of the vertical change to the corresponding horizontal change. And that rise over run can be generalized a little bit using the slope formula, y2 minus y1. So what that means is that in the top of this fraction, you are finding the differences in y values for two ordered pairs. And the horizontal change, the run, x2 minus x1, that's where you're finding the differences in the x values. It's important to note here that x should not equal 0. Alright, so the bottom of the fraction can't equal 0, and that's because division by 0 is undefined. So when that happens, we say that the slope is undefined. So let's take a look at example number 1. In this example, what we want to do is find the slope of the line that passes through these points, and we are going to use the slope formula that was given above to do this. So if we take a look, what we have is we have our x1, y1, x2, y2. We're just going to plug those into the formula very quickly. 4 minus negative 3 over negative 5 minus 2. So 4 minus negative 3, that's 7. Negative 5 minus 2 is negative 7. Negative 7 divided into positive 7 is negative 1. The slope of the line passing through those 2 points is negative 1. There are 4 different ways that the slope of a line can be classified. All right, we talk about lines that have positive slope, and these are lines that rise from left to right. We talk about lines that have negative slope, and these fall from left to right. We talk about a horizontal line. We talked about that concept very, very quickly when we were dealing with intervals that might be constant. All right, so a horizontal line has constant features, all right, or the intervals would be constant, and that means that there is no rise to that line. We also talk about undefined slope. That's a vertical line, all right, and there would be no horizontal run to that line. So there's 3 different ways that we can represent the equation of a line, and the first one is called slope-intercept form. In slope-intercept form, y equals mx plus b. The m is the slope of the line, and the b is the y-intercept. If you recall from our work with function basics, the y-intercept is the location where the graph would cross the y-axis. So when you're working with this form, you have a slope and a y-intercept, which is why it's called slope-intercept form. So let's look at example 2 here. What is an equation for the line that has a slope of 5 and a y-intercept of 0, negative 2? What we really care about here, all right, is the fact that this ordered pair is a 0b. So it's this second value that we really want to work with. So using our y equals mx plus b form and plugging in that slope of 5 and that y-intercept of negative 2, we would get y equals 5x minus 2. We can take an equation that's not in slope-intercept form and write it in that y equals mx plus b form by solving for y. So let's take a look at example 3. We want to write this equation in slope-intercept form and then identify the slope and y-intercept. To write it in slope-intercept form, we want to first isolate the y. So let's subtract 3x from both sides. That gives us negative 4y equals negative 3x plus 8. Next, we're going to divide by negative 4 in all of these spots, and we get y equals 3/4 x minus 2. The slope of this line is right before the x, all right? It's the coefficient of the x, and that would be 3/4. The y-intercept is the b value, which would be -2. Last piece here is going to be graphing lines that are presented in slope-intercept form. All right, in order to do so, we need this to have been solved for y. So what's going to happen here is we have to add 1/3 x to both sides, and we get 1/3 x plus 4. Here, our y-intercept is 4, and our slope is 1/3. Begin by plotting the y-intercept on the y-axis. Next, count using the slope, a rise of 1 and a run of 3. A rise of 1 and a run of 3. We can go up 1 and to the right 3. We can also go down 1 and to the left 3. We would use a ruler, all right, which I do not have great access to at this program, to draw a line through those points with arrows on the end. The second way that we can represent a linear function is using what's called the point-slope form. In this form, m is still the slope of the line. But the other pieces of information are this y1 and x1. Together, they form an ordered pair for one particular point that's on the line. Looking at example 5, we know that a line passes through the point 7, -1 and has a slope of 2/3. What is an equation for that line? Well, using our point-slope form, as we have above, let's plug in the different pieces. So our y1 coordinate was -1. Our m, or our slope, was 2/3, and our x1 coordinate was 7. Simplifying the double negative here, we get y plus 1 equals 2/3 times x minus 7. Let's talk for a minute about what the directions said. What is an equation? That's all they asked you for, an equation. Technically, you have written an equation. My advice here is don't do too much. This, the point-slope form, is an acceptable stopping point because they asked just generally for what is an equation. It's not necessary to write it in slope-intercept form unless you are specifically asked for the equation in slope-intercept form. In the next example, we're going to look at a case where we start with two ordered pairs. Point-slope form implies that we need a point and a slope. So if we take a look at example 6, we have 2 points to choose from, but we're missing a slope. That makes this example a little bit harder because we have to find the slope of the line through those 2 points before we can write the equation. Going back to the first topic that we talked about today, which was slope, let's find the slope of the line using that slope formula. Subtract the y values, so this case would be 1 minus 3, and then subtract the x values, so -5 minus 2. The slope of the line passing through these 2 points is 2/7. So we need 1 point and the slope to write the equation of the line. It doesn't matter which point we use. So a fair answer would be y minus 3 equals 2/7 times x minus 2. We also could have written the equation y minus 1 equals 2/7 times x plus 5. Again, going back to my point in the previous example, don't do too much. It doesn't say what type of an equation we have to write or what form it needs to be in, so stopping with the point-slope form is an acceptable answer. You could solve for y by distributing and then adding the y1 value, but it's extra work. It's something that you don't have to do. In example number 7, we are asked to graph the equation y minus 3 equals 2 times x plus 1. We again have to pick out some very important information. So the first thing we want is the point that's in the equation. That's the x1 and y1 values. We have to be careful, though, to switch the signs on those coordinates. That happens because the original equation, the general form, has subtraction in it. We also need the slope, which in this case is 2. Plot the point, -1, 3, and then count. 2 is like 2 over 1. So the rise in this case is 2, we go up 2, and the run is 1, so we'll go to the right 1. Up 2, right 1. We can also go down 2 and left 1. Again, we would use a ruler to connect the dots, draw arrows on the end, and that's the graph of that equation. Final form is standard form, and standard form is ax plus by equals c, where a, b, and c are real numbers, and a and b cannot both be 0 at the same time. Standard form doesn't really have a whole lot of uses outside of some application problems. So you're never going to be asked to write an equation in standard form. It just sometimes is a useful way to use information in a given problem. You will, however, be presented with equations in standard form, like the one here. And when you're asked to graph equations in standard form, you could solve for y like we've seen before, and put it in slope-intercept form, but you can also use the concept of intercepts, which we discussed in our function basics lesson. One thing that we discussed in that function basics lesson is the important feature of intercepts. So for example, that in an x-intercept, all right, you have your x value and then the y coordinate 0. In a y-intercept, the x coordinate 0 and then you have your y value. That's going to help us out when we're given a linear equation in standard form, because what we can do is, if we're trying to find an x-intercept, then let's replace the variable y with 0, because we know that that coordinate would be 0. That would leave us with 2x equals 8, and we would know that x equals 4. That means that we know that the graph crosses the x-axis at the value 4. For the y-intercept, we could replace the x value with 0, leaving us with 4y equals 8, and we would get a y value of 2. That means we know that this graph crosses the y-axis at 2. It only takes 2 points to get a line, so we could draw the line just through those 2 points. Another key concept for us here is the idea of parallel and perpendicular lines. You discussed parallel and perpendicular lines a great deal last year in geometry. You also discussed them in Algebra 1. For parallel lines, it's important to understand that the slopes are equal. For perpendicular lines, the slopes are negative reciprocals of each other, or opposite reciprocals. Parallel lines never cross, so the rise and run on both of those lines, the ratio of horizontal change to vertical change, or vertical change to horizontal change rather, would have to be the same. Perpendicular lines meet at exactly at a 90-degree angle, so we're going to have to flip the slopes and also change the sign. It's important to understand here that no line can be vertical when we're talking about parallel and perpendicular lines. All right, kind of counterintuitive there, because we know that like vertical lines could be parallel, and that if we have a horizontal line, a perpendicular line a vertical line would be perpendicular to a horizontal line, but it's just part of the technical definition. In example 9, what is an equation of a line that is parallel to y equals 5x minus 2 and goes through 2, 4? What we need from this given equation is the slope. Y equals mx plus b. So the slope is the m value, or the coefficient of x, so here the slope is 5. We have a slope and a point. All right, we were not given an intercept. So we're going to use point-slope form, which we saw a few slides ago. Plugging in the values, we would get y minus 4 equals 5 times x minus 2. We kept the slope the same because we were asked for a line that was parallel. In example 10, what is the equation of a line that is perpendicular to this one? Again, we want to pick out the slope here. Here our slope is negative 1/4. But because we're asked for a perpendicular line, this needs to change. Flip the sign, it was negative, so it's going to become positive. And flip the fraction, it was 1/4, so we're going to use 4/1, which means the slope that we want to use is 4. And through 0, 2. This is very specifically a y-intercept. It's a b value. So because we have a y-intercept and our slope, we can use our slope-intercept form. Plugging in these values, we would get y equals 4x plus 2. This was a very, very quick review of the basic properties of linear functions. I encourage you now to look back at your notes and figure out what might have been unclear. Maybe rewatch just that section in the video, and if you still don't understand, mark that example, all right, as something that you want to ask a follow-up question on during our next class.